Hello everyone, my name is Minko Gechev. I am an engineer on the Angular team at Google. In this workshop, we're going to build a kanban board with Angular and Firebase. Our final application will have three categories of tasks: backlog, in progress, and completed. We will be able to create, delete tasks, and transfer them from one category to another using drag and drop. We will develop the user interface with Angular and use Firestore as our persistent storage. At the end of the workshop, we will deploy the application to Firebase hosting. Today, you'll learn how to use Angular Material and the Angular CDK, how to add Firebase integration to your Angular application, how to keep your persistent data in Firestore, and how to deploy your app to Firebase hosting using the Angular CLI with just a single command. Keep in mind that this workshop assumes that you have a Google account and a basic understanding of Angular and the Angular CLI. Now let us get started. First, let us create a new Angular CLI workspace. In the terminal, run the command ng-new kanban fire. For the purpose of this exercise, we will not depend on the Angular router and will be using CSS. This step may take a few minutes. Angular CLI will create the project structure and install all of its dependencies. When it's done, go to kanban fire directory and start the CLI's development server by running ngserve. Then open localhost port 4200 and we'll see an output similar to this screen. Now open the apps components template and delete its entire content. When we navigate back to localhost port 4200, we'll see a blank page. Angular comes with an implementation of user interface components following the material design specification as part of the Angular material package. One of the dependencies of Angular Material is the Angular Components Development Kit, or the CDK. The CDK provides primitives such as accessibility utilities, drag and drop, overlays, and so much more. To add material to the app, we're going to run ng-add Angular Material. This command will first ask us to pick a theme, if we want to use global material typography styles, and if we would want to set up the browser animations for Angular Material. The ng-add command will install Angular Material and also add the Angular CDK to package.json. As the next step, we can start using the components that Angular Material has to offer. Let us add a toolbar and an icon to app component. Open app component HTML and add a toolbar with nested material design local fire department icon and a span with the text kanban fire. If you look at the console now, we'll see that Angular throws a few errors. They're caused by us not having the components we're using in the app components template. To fix them, we'll import mat toolbar module and mat icon module in app module. We'll also update the color of the mat toolbar and set it to the primary color of our material theme. When we open the app now, on the screen we will see a page with blue toolbar and a blank content. That's definitely not bad for just 4 lines of HTML and 2 imports, right? As the next step, let us create a component that we can use to visualize the tasks in our kanban board. Go to the src app directory and generate a component called task. This command will not only generate the component, but it will also add its declaration to the app module. Inside the app directory, we'll create a file called task.ts. We'll use this file to define the interface of the tasks in our kanban board. Each task will have an optional ID, title, and description fields, and all of them are going to be of type string. Now let us update task.component.ts. We want task component to accept as an input an object of type task, and we want it to have an edit output. We will emit this output when the user double clicks on a task. Now let us update the tasks template. We want to visualize the individual task as material design cards with class name item. On double click on a card, we want to emit the edit output. Inside the card, we want to visualize the title of the task inside of a H2 element and its description within a paragraph. Notice that we are now getting errors in the console that math card is not a known element. To fix this issue, all we need to do is import math card module in app module. Next, we will create a few tasks in the app components and visualize them using the task component. In app component, define an array called to-do, and inside of it, add two tasks. For example, I'm quite thirsty today, so I would want to buy milk and I'll have to go to the store to do this. I'd also want to create a Kanban board. Now, to the bottom of the app component HTML, we'll add an ng4 directive, which iterates over all of the to-dos in our list and for each one of them renders a separate task. When we open the browser, we'll see the following screen. We're ready for the fun part now. We'll create 3 swim lanes for the 3 different states task could be in and enable drag and drop between them using the Angular CDK. First, we'll import the drag-drop module in app module from the Angular CDK drag-drop package. After that, we'll remove the app task component from the app components template. We're going to replace this content with the following structure. First, we'll create a top-level div with class content wrapper. We'll use it to wrap all our swim lanes together with the logic for adding new tasks that we're going to add just in a little bit. After that, we'll create a div with the class container wrapper, which has 3 nested containers inside of it. Each one of the containers has a title under an H2 element. We have one for the backlog, one for the in-progress tasks, and one for the completed tasks. We'll also create a material card, which will contain the individual tasks for each container. Now let us first focus on the first material card for the backlog and after that implement the same functionality for the in-progress and done columns. Since we want to drag and drop tasks across swim lanes, we will add the CDK drop list directive to the material design card. We'll also assign an ID and also a getter reference to the CDK drop list directive using a template variable called to-do list. After that, we'll set the CDK drop list data, which in this case is going to be our to-do array. Next, we'll handle the CDK drop list dropped event by invoking the drop method. Since we want to be able to transfer tasks between the 3 columns, we'll use the CDK drop list connected to input. Here we will pass an array with the template references to the other CDK drop lists that we're going to create just in a little bit. As the next step, let us use the ng4 directive on top of the app task to visualize the individual tasks that belong to the current swim lane. When the user wants to edit a task, we'll call the edit task method, passing the name of the array associated with this current swim lane and also the task that we want to edit. Don't forget to add the CDK drag directive to the tasks since we want to make them draggable. Now in app component, let us add the in progress and done arrays. As the next step, let us repeat the same process for the in progress and done swim lanes. We also want to handle the case when we have 0 tasks. In such a case, we can just show the empty list label. To make this all work, we need to define the drop method in the app component. Inside of it, we'll first perform a check if we're dropping in the same list from which the task is coming from. If that's the case, then we immediately return. Otherwise, we transfer the current task to the destination list. To do this, we are going to use the transfer array item function that comes from the Angular CDK. Notice that we are not handling the case of reordering tasks in the same swim lane. For simplicity, we're going to omit this functionality from the workshop, but feel free to implement it on your own using the CDK's documentation. Finally, let us add dummy implementation of the edit method to make the Angular compiler happy. Now we are ready just to drag and drop tasks around. As the next step, let us implement the functionality for creating new tasks. For the purpose, we'll add a button that will open the new task dialog. Inside the button, we'll have a material design add icon and the add task label. Since this button uses the material button component, we'll need to import the corresponding module in the app module. Now in the app component, let us implement the functionality for adding tasks. For the purpose, we're just going to inject a material design dialog in the constructor of the component. Inside the new task method in the app component, we'll open the dialog based on the task dialog component, which we're going to declare in a little bit. We're going to set its width to 270 pixels and pass a data object. Using the data object, we'll be able to pass data to the task dialog component later on. Notice that since we expect to populate the fields of the task in the dialog, we're here passing just an empty object. After that, we subscribe to the after close observable, and inside of the callback, we take the result from the dialog and push it to the list of to-dos. This may seem like magic, but when we implement the task dialog component, things will get so much more clear. As a next step, we need to import the mat dialog module in app module. Now let us create the task dialog component. Just go to src app and run ng-generate component task dialog. To implement its functionality, we'll first open the template of the component. Here we'll create a form field with a label title. We'll also add an input that uses the directive mat input and the CDK focus initial, so that when the user opens the dialog, the mat input is automatically on focus. After that, we're also going to apply two-way data binding to the data task title by using ng model. And for the purpose, you're going to take advantage of the banana in a box syntax. We'll create a similar field for the description, but this time we're going to take advantage of the text area field instead of using a text input. As the footer of the dialog, we're going to use two buttons inside of a container with the mat dialog actions directive on top of it. The first one of the buttons will have a label OK. It will be handling the creation of new tasks. Using it, we're going to close the dialog with mat dialog close directive and pass the task as a result. This result will later go directly to the callback that we use to subscribe to the after close event in the app component. When the user clicks the cancel button, we're going to call the cancel method declared in the dialog's controller. Now let us implement the controller of the component. Inside of its constructor, we would want to inject a reference to a material dialog and also the dialog data. The dialog data will have a shape defined by the task dialog data interface. This interface has two fields: task, which contains subset of the fields of the task object, and also the enable delete property, which we will use to instruct the dialog that the deleting task feature should be enabled. Inside the task dialog component, we also have a private property called backup task, which will contain the original fields of the task object. Now let us implement the cancel method. Inside of it, we will first restore the title and the description, and right after that, we're going to close the dialog passing the data object. There is one more interface that we would want to implement here. This is the task dialog result interface that we use inside of the callback of the after close observable we subscribed to in the app component. The next thing we need to do before completing the add task functionality is to import a few modules in the app module. We need the forms module because of the ng model directive, as well as the mod input module for Angular material input. And the final things we need to do is just go to the app component and import the task dialog component and the task dialog result. After this, we'll just need to open the UI and click on the add task button so that we can preview the functionality that we just implemented. Submitting a form will automatically add the to-do item to our backlog. As a next step, we'll improve the layout of the application to make it more visually appealing by tweaking the styles a little bit. We want to position the swim lanes next to each other. We'll also want to add some minor adjustments of the add task button and the empty list label. For the purpose, we're going to go to the app component CSS and add a few styles. First, let us just add some bottom margins to our material toolbar. After that, we can just add some left margin to the label inside of the toolbar. Next, let us set the max width of the content wrapper to 1400 pixels and set its margin to auto to center it horizontally. To position the swim lanes next to each other, we're going to declare styles for the container wrapper. We'll set its display to flex and also justify content to space around. Each swim lane here uses the container class name. We'll set the width of the element with this class to 400 pixels and also add a few margins. For the list of tasks, here we have just 1 pixel solid gray border, minimum height of 60 pixels and a border radius of 4 pixels. The new task button should be with a 30 pixel bottom margin. For the empty label, we're going to just set the font size to 2em, 10 pixel for bottom padding, align the text at the center, and also set the opacity to 0.2. As a next step, we would also want to improve the CDK styles. By default, when we start dragging an item, the Angular CDK will create a placeholder, which we would want to hide. For the purpose, we're going to set its opacity to 0. To ensure smooth transition when we drop a task, we would want to set a 250 millisecond transition in the CDK drag animating class. Finally, let us update the task styles. Its host element should be using display block and the tasks should be positioned 10 pixels away from each other with a cursor pointer. Once the app reloads, we're going to get a much better looking UI. To edit and remove existing tasks, we're going to reuse most of the functionality that we already developed. When the user double-clicks on a task, we're going to open the task dialog component and populate the two fields in the form with the task's title and description. The only change we need to make in the task dialog component is in its template, where we need to add a button that should be visible only when the data enable delete is true. This button will use the primary color of our material design theme, and on click will emit an object with the current task from the dialog's data and a delete property with value true. Inside the button, we'll use a material delete icon. The rest of the implementation of the edit and delete functionality is in the app component. The edit task method will now accept the list, which is a union type from the string literals done, to do, and in progress. It will also accept a task. Inside of it, we're going to open the task dialog component with width 270 pixels, and as dialog data, we're going to pass the current task and set its enable delete property to true. After the user closes the dialog, we want to get the current list and find the index of the task that we're currently editing or deleting. After that, based on the delete flag of the result object, we want to either delete the task or update it. And here it is. We can now edit or delete existing tasks in the board. As the next step, let us create a new Firebase project. Go to Firebase console, click Add Project, use Kanban Fire Workshop as its name, and also configure your Google Analytics account, and next just click Continue. As the next step, let us integrate our project with Firebase. The Firebase team offers the package Angular Fire, which provides integration between Angular and Firebase. To add Firebase support to the app, we're going to open the workspace root directory and just run ng-add Angular Fire. This command will install the Angular Fire package and show us a few prompts with questions. Typically, it will first ask us if we wanted to collect error reporting information. After that, if we haven't authenticated, the ng-add command will open a browser window and ask us to copy a token that we'll need to paste in the terminal afterwards. Since I have already authenticated in this particular example, it will just ask us to select a Firebase project. Here we can pick a Kanban Fire Workshop. As a next step, we need to create a Firestore database. Under Cloud Firestore, click Create Database. After that, select Start in Test Mode. Finally, select a region and click Enable. The only thing left now is to add the Firebase configuration to our environment. Click on the gear icon next to Project Overview and select Project Settings. Under Your Apps, select Web App. As a next step, register your application, and here we just need to make sure that we enable Firebase hosting. After we click Register App, we can click on Next and continue to console. Here you select Config, and now we can just copy the configuration into our development and production environment files. Keep in mind that for production application, we would want to have two separate configurations. For more information, check this link. Once we have set up the Firebase SDK, let us add Angular Fire to move our data to Firestore. First, we'll need to import the modules that we need in app module and pass the configuration we just set in environment.ts. After that, open app component and inside of its constructor, inject an instance of the Angular Firestore provider as a private property called store. As a next step, we'll want to use Firestore to initialize our to-do collection. For the purpose, we can just use our collection method of Firestore and pass the name of the corresponding collection from our Firestore database. Let's just call it to-do. To subscribe for changes, we need to invoke the value changes method, which returns an observable. The observable will emit new values every time when the collection changes. After that, we would also have to configure the Firestore to use ID as an ID field. Now we will just need to repeat the exact same process for the other two fields. Since we're working with observables instead of arrays, we also have to update the way we add, edit, and remove tasks, and also the functionality for moving tasks across swim lanes. Instead of mutating our in-memory arrays here, we'll need to use the Firebase SDK to update the data in our database. First, let us just look at how we're reordering tasks. We would want to remove the tasks from the current swim lane and move it to the one where the user has dropped it in. We will delete the task from the previous collection by first retrieving the collection and after that deleting the document, and after that we'll just create the task in the next collection. Notice that we wrapped everything into a single transaction just to ensure that the operation is atomic. Next, let us update the edit task method so that it can use Firestore. Inside of the close dialog handler, we need to check if the result of the dialog is a delete action and either delete the current task or update it. Finally, we'll need to update the functionality for creating new tasks. Just replace this todo.push task with this store collection todo at result task. Notice that now our collections are not arrays but observables. To visualize them, we need to update the template of the app component. This will be quite simple actually. Everything we need to do is just replace every access of to-do, in progress, and done properties with respectively to-do pipe async, in progress pipe async, and done pipe async. The async pipe will automatically subscribe to observables associated with the collection. When the observable emits new value, Angular will automatically run change detection and process the emitted array. Now when we create a new task, it will still exist after a page refresh. We can also open Firestore to verify that the task is in our database. In the application currently we perform optimistic updates. We have our source of truth in Firestore, but at the same time we have local copies of the tasks. When any of the observables associated with a collection emits, we get an array of tasks. When we move a task from one swim lane to another, we invoke transfer array item, which operates on the local instances of the arrays that are representing the tasks in which swim lane. The Firebase SDK treats these arrays as immutable, meaning that the next time Angular runs change detection, we will get new instances of them, which will render the previous state before we transfer the task. At the same time, we'll trigger a Firestore update and the Firebase SDK will trigger an update with the correct values, so in a few milliseconds the UI will get into its correct state. This will make the task just transfer jump from its first list to the second one. The right way to solve this problem depends from application to application, but in all cases we need to ensure that we're maintaining consistent states until our data updates. For the purpose, we're going to take advantage of behavior subject, which will wrap the original observable we receive from value changes. Under the hood, behavior subject will keep a mutable array which will persist the update from transfer array item. To implement a fix, all we need to do is update app component. First, we'll define a function called getObservable. This function will accept Firestore collection with its type parameter task. Inside of the body of this function, we're going to create a new behavior subject and pass an empty array as its default value. We'll subscribe for changes to the collection specifying ID fields to be ID and emit the task via the behavior subject. Finally, we'll just return the subject. When we wrap the collection inside of a getObservable call, we'll fix the problem because behavior subject will persist the value across change detection runs. This way we will be able to transfer from the first to the second collection without leaving the data in an inconsistent state. And there is the result. Let's just add one more task here as well. To deploy our kanban boards to Firebase hosting, all we need to do is just run ng-deploy. This command will first build our application with its production configuration, applying a lot of compile time optimizations. After that, it will deploy to Firebase hosting and output a URL, which will allow us to preview the result. Clicking on the URL, we will see the exact same tasks we created locally, although this time we're going to access the app via Firebase hosting. Before we complete the workshop, I would want to give you a few more pointers for further development. Remember that we deployed the application using test configuration here. Before deploying your application to production, make sure that you set up the correct permissions. You can learn more about this here. Another thing to keep in mind is that currently we don't preserve the order of the individual tasks in a particular swim lane. To implement this functionality, you can use a metadata field keeping track of the position a given task has compared to other tasks in the swim lane. Additionally, we built the Kanban board for only a single user, which means that we have only a single Kanban board for anyone who opens the application. To implement separate boards for different users of the application, we'll also need to change the structure of the database. You can learn more about Firestore's best practices here. That was pretty much everything. Thank you very much for watching this workshop. You can find me on Twitter at am Gechev. I just wish you happy coding. Until next time.